Or to the cloud. Okay, perfect. Well, first, let me ask, so do you guys have any specific question with the review sheet or the homework that you want me to start with? I mean, if you have any question, guys, please let me know. You have any specific question about the review sheet,
So
about
for now with
homework?
the not with the review sheet, but with last class, there was
Uh,
with the exercise that you had given of x squared minus 4x plus 3. I was wondering if you could go over that.
okay, yeah, I can start with that. I mean, actually, there's I mean, a similar problem in the review sheet, right? The problem number 6. Yeah, so we can do that too. Yeah, sure. Okay, so this is from section. So this is section 2.2, right? Um, okay, so the function was f of x. Well, let's do the one from the homework. I mean, both are. I mean, it's just the same problem, right? Just a different function. This would be then problem number 6 in the review sheet. Problem 6 in the review sheet. Right. So so f of x. So I'm gonna do the one from the review sheet. All right. I mean, it's just different numbers, but the same same way to solve the problem. So it's minus x squared uh, plus 4x minus 2. Okay. So so A, first you have to find the vertex. Find the vertex. So of course this is a quadratic function, right? Because we have minus x squared. I mean, the highest power of x here is 2, so that's a quadratic function. The graph of a quadratic function is a parabola, right? And so first we can find the vertex. So let me just remind you. So the formula of the vertex, so the x coordinate, of the vertex. I mean, the vertex, it's a point, right? So it's a point in the it's a point, so it has a x coordinate and the y coordinate. So the x coordinate is given by minus b over 2a, right? So like here in this function f, the a, so this is supposed to be of the form ax squared, plus bx plus c, right? So your a should be the -1, b is the positive 4, and your c is the -2, right? So so your x coordinate is actually minus b. So it's minus, so with b we said it's positive 4. So minus 4 over 2 times a, it's a -1, right? So 2 times -1. So that would be minus 4 over 2 times -1. It's -2, of course. Negative over negative is positive, and 4 over 2 is, of course, 2. So that's positive 2, right? That's the x coordinate of the vertex. All right, so you need to, so you need to memorize this formula, guys. So you need to know that for the vertex, the x coordinate, it's minus b over 2a, right? Now, the y coordinate. So for the y coordinate, guys, all you have to do is to plug this positive 2 in the function f, right? So you have to compute f of your negative b over 2a. And negative b over 2a turns out to be positive 2. So this is f of positive 2. Okay. So you have to plug in 2 in the function f. So it's minus x squared. So it's minus 2 squared plus 4 times x, which is positive 2, minus 2, right? So your f of 2 is equal to, so 2 squared is 4, so that's negative 4 plus 8 minus 2. Negative 4 plus 8, it's positive 4. Positive 4 minus 2, it's positive 2. So this is f of 2 is positive 2. All right. I mean, I think in the problem we had the last time, the x coordinate was a fraction, right? And when it's a fraction and you want to compute the f of the the fraction, then sometimes with the fraction you're gonna end up with a lot of computations, right? But I guess in the test you should expect just to have like a whole number, okay, for the x coordinate, because again, if you have a fraction, then it's gonna be a lot of computations, right? So anyway, so this y coordinate is of the vertex is positive 2. So here the answer should be, so your vertex, the vertex is the point. So the x coordinate is positive 2, and so that's your x coordinate, and the y coordinate, it's also positive 2. Okay, so then the vertex would be the x coordinate, the positive 2, and then the y coordinate, which is also positive 2, right? Of course, here it's just a coincidence. I mean, the x coordinate is the same as the y coordinate, right? It's 2, 2, but this is just a coincidence, okay? I mean, in general, the x coordinate and the y coordinate, they don't have to be the same, right? So is there any question about the vertex, guys? So again, the formula you need to apply is this one here, the minus b over 2a. Okay. And then for the y coordinate, you have to plug the value in the function f of x. Okay. Now b, you have to find, so now b, you have to find the x-intercept and the y-intercept. So let's start with the x-intercept. X-intercept, again, that will be the intersection of the graph with the x-axis, all right? And to find the x-intercept, you have to solve f of x equals to 0, all right? So that's how we find the x-intercepts. So we have to solve minus x squared plus 4x minus 2 equals to 0, all right? So well, here, of course, you can factor, but probably my advice would be just to use the quadratic formula, right? So you can just use quadratic formula, and so your x would be minus b, so that's in minus 4, plus or minus square root of b squared. So b squared, that's 4 squared, minus 4 times a, that's negative 1, and then times c, that's negative 2, okay, over 2a. So then your x, it's negative 4 plus or minus square root of, so we have 16 minus, you have negative times negative, that would be positive. So this negative here times this negative would be positive. So it's actually 8 minus 4 times 2, that would be 8. So it's 16 minus 8, so it's the square root of 8. So this is plus or minus square root of 8 over 2 times a, so it's 2 times, where's a? So a is, of course, is negative, a is negative 1, right? So it's 2 times negative 1. Okay. So so that would be, so x, so the solutions are So first solution, let's say you have plus, so that's negative 4 plus square root of 8 over negative 2, and x equals to negative 4 minus square root of 8 over negative 2. All right, so then your answer should be the following. Find answer. So the x-intercepts are, so your first solution is negative 4 plus square root of 8 over negative 2. And then for the x-intercept, the y is always 0. So here's a 0. So this is always 0. All right. And then second x-intercept is this negative 4 minus square root of 8 over, sorry, here I forgot negative 2 here. This is negative 2. So over negative 2. All right. And then 0. Okay. Actually, here for this x equals to negative 4 minus square root of 8 over negative 2. I mean, you have, it's negative in the top, it's negative in the bottom. So negative over negative, that would be positive. So this is actually, this is positive here. Okay, so this is plus. Okay, it's negative over negative, so it's positive. Okay, so that's for the x-intercept. Remember, guys, x-intercept, you solve the function equals to 0, right? Now, for the y-intercept, so now for the y-intercept.
So when the equation is like that, we cannot simplify it further.
Simplify the answer.
Yeah.
Like the.
Yeah, so we should have to leave it negative 4 plus square root of 8.
Yeah, that would be a fine answer. You cannot really, well, of course, here square root of 8, you can write square root of 8 like 2 times the square root of 2, right? So you can try to simplify, but I mean, it's fine. Even if you don't simplify here, it's fine. All right.
Okay.
Okay. So that's for the x-intercept. Now for the y-intercept, where's the y-intercept? So the y-intercept, you have to.
Wait, I was curious. Why does the negative 4 become positive? Like
For the second solution.
Yeah.
Yeah, because I was saying there's a negative 2 in the bottom, right? So it's negative over negative, so that's why it becomes positive.
So then wouldn't the first solution also be positive 4?
Yeah, well, because that would be positive 4, but then there's this, there's this plus square root of 8, right? So if you're gonna change the sign, you have to change the sign of the 4 and the square root of 8. So that'll be like plus 4 minus square root of 8.
Okay, I got you.
I mean, it's up to you. Sure, you can do that too. I mean,
all right.
So the y-intercept, well, for the y-intercept, guys, you have to evaluate the y-intercept. That's the intersection of the y-axis with the graph, right? So you have to evaluate f of 0. Okay, just plug 0 into the function f. So if you plug 0, let's see, where is f? F is so it's minus. So that would be minus 0 square, minus 0 square. Plus 4 times 0, and then minus 2. Okay, so then f of 0 would be negative 2. Okay. So then, so your answer should be, answer here, so the y-intercept is, so x is always 0, so I'm gonna put 0 here, and then we got negative 2, so that's my y-intercept. So this x here is always 0. This is always 0 in the y-intercept. X is always 0, right? Any questions, guys? Okay. Now the C, you have to find the axis of symmetry. So for the axis of symmetry, I mean the axis of symmetry is the same as the equation of the axis of symmetry is the same as for the vertex coordinate of the vertex. So for C, so the axis of symmetry. Okay, so then you have the formula is the following. So it's x equals to minus b over 2a. So remember, guys, the axis of symmetry, it's actually a vertical line. It's always a vertical line. So axis of symmetry of a parabola is always a vertical line, and it passes through the vertex. So that's why it's the equation of the axis of symmetry is the same as the x coordinate of the vertex, right? Because it passes through the vertex. And minus b over 2a, of course, that would be the minus 4 over 2 times the negative 1. So that's a negative 4 over negative 2. So that again, that's positive 2. Okay. So axis of symmetry is x equals to 2. Axis of symmetry. That's x equals to positive 2. Right? Okay. So then D. In D, the question is whether f has a maximum or minimum and its coordinates, right? So remember, guys, we said if you have a parabola, then there are two cases. If a is positive, then the parabola opens up. If a is negative, then the parabola opens down, right? So if the parabola opens up, then the vertex would be, we are in this the following situation where, so if the parabola opens up, then the vertex would be a global minimum, right? Minimum, right? So this is when a is positive. Now, if a is negative, then your vertex is going to be, so this is your vertex, of course. So then your vertex is going to be a global maximum. Right? So this is when a is negative. Right? So in our example here, a is negative 1, so it's negative. So a it's equal to negative 1, so it's negative. So then is negative. Okay, so then the parabola is, so then the parabola opens down. The parabola opens down, and so the vertex, so the vertex is a global maximum. Okay, so your answer, whether f has a maximum or minimum, so f has a maximum. So final answer, the answer should be the following. So answer, so f has a maximum. Sorry, maximum. And the coordinates, so the maximum would be is the vertex. Okay, so it's the vertex, which is positive 2, positive 2. Right? So that's our maximum. Of course, f actually doesn't have a minimum, right? Because the parabola opens down, so it goes all the way down. So there is no minimum, right? Okay. Now, now we have to use all these informations to sketch the graph of f, right? So now we're going to graph f. So now we're going to graph f, graph f of x. All right, so to graph f of x, guys, first you have to plot the vertex, the x-intercepts, and the y-intercepts. All right, so first thing to do, you have to plot vertex, x and y-intercepts. Okay, so let's do that. So here, so here's the graph. So I'm gonna need probably some 1, 2. I'm gonna need 1, 2, etc. All right. Probably I'm gonna need -2. So this is -1, of course, -2. Right. So first, let's start with the vertex. Vertex, we said it's +2, +2. Right. So my vertex. So this is +2, +2. So here's my vertex. Right. So this is my vertex. So this is +2, +2, right? Next, x-intercept. So x-intercepts, we said, let's see, x-intercept. So we had, let me just remind you, the x-intercept, where is it? So we have -4 plus or minus square root of 8. So we have -4, plus square root of 8 over -2, and 4 plus square root of 8 over, sorry, this is -2 over +2. All right. So here with the square root, with the square root of 8, guys, I mean, you can just, you can try with the calculator to approximate this number here, right? I mean, if you approximate, I mean, if you try to compute the square root of 8 with a calculator, I mean, it's a number between 2 and 3, right? And this is, yes, sure, it's recorded. Yeah, the lecture is recorded, yes. So this is, anyway, so you can use a calculator, okay, to approximate this number, right? So that will be actually, I think it's gonna be, I think 0 point something, okay? It's, I think 0.8 or something, okay? This is positive 0.8, I think. All right, and this one here, I think, is gonna be 3 point. This is, I think, 3 point something, probably 3 or 4. All right, so you can approximate the x-intercept if you have a square root, right, with the calculator. So let's say this is 0.8. Let's say it's somewhere here, right? And then the 4 plus square root of 8 over 2, we said it's 3 point something, so it's right after 3 here. Okay, I mean, it doesn't have to be the exact value, right? It's, if it's a square root or something, then you can just try to approximate the number, right? Then you have the y-intercept. So the y-intercept, we said it's 0, -2, right? And so here's my 0, -2. So here's my y-intercept, okay? So this is my y-intercept. This is my x-intercepts. X-intercept. All right. Now I have to draw the the axis of symmetry. So here's my axis of symmetry is the same. So the axis of symmetry, guys, again, it passes through the vertex. It's a vertical line and passes through the vertex. So here's my vertical line passing through the vertex. And that's my axis of symmetry. So this
Then
is, yes.
on the test, will we have a question like this, like where the x and y intercepts are fractions, or would they be whole numbers?
No, I guess they're going to be fractions. So they're going to be fractions, I guess. I mean, of course, I'm going to try to do my best to give you something which is kind of simple to compute. But sometimes, I mean, you're going to end up, you know, if you end up with a fraction, just try to approximate the fraction. I mean, it doesn't have to be the exact value, right?
Okay.
Yeah. So, okay, so now, now the parabola opens down, right? This is my vertex. So I'm gonna just now I'm gonna connect the points. So this is my vertex. So it goes all the way down here. And then on the other side, it goes, so this is my x-intercept. This is my y-intercept, and it goes all the way down here, right? So this would be my the graph of f of x. So this is my f of x, right? So I mean, once you plot the vertex, the x, y intercept, then basically all you have to do is just you know, connect the points. But just be careful. I mean, when a is positive, you know your parabola open up. If a is negative, then your parabola opens down, right? So yeah. Is there any other question, guys? I see there are messages in the chat. Okay.
Can we do the first page of the review?
Yeah, sure. So okay. So I guess there's no question for this parabola. All right. So yeah, okay. So now let's move to the problem number 1 in the review. The first question in the review, right? Or the question number 2? Or first you said first page, right?
Yeah.
Okay. Okay, so let's start with problem number 1. So problem number 1. So this is from,
homework, right?
excuse me?
We don't have any homework.
No, there's no homework 6. No, there's no homework. It's just this is, yeah, this is just the review. Yeah.
Okay.
There's no homework. So this is problem number 1 from the review sheet. No, but of course, if you have any questions about the homeworks, I can answer them. So for number 1, guys, you have to determine whether y is a function of x. All right. So whether y is a function of x. So there are 2 cases. If you have an equation, so to determine whether y is a function of x. Okay, so there are 2 cases. Case number 1 is when you have an equation. So if you have an equation, then you have to solve for y. So case 1. So you have an equation, then you have to solve for y. Okay. Case number 2. So if you have a graph, then you can use the vertical line test. So in case of a graph, so if you have a graph in the case number 2, then use the vertical line test. Right? So like here in the review sheet, so first question, well, the a, it's obviously an equation, right? So for a, for example, a, you have x squared plus y squared equals to 5. So obviously this is an equation, right? So I have to solve for y. So we have to solve for y. Solve for y. Okay. So of course you can 5. So you can, subtract x squared from both sides. So then y squared would be 5 minus x squared. Then you apply square root. This is my square root both sides. But of course, because of the even power, so this is even, then we're going to need the plus or minus here. Okay, so then y, would be plus or minus square root of 5 minus x squared. Okay, so just be careful, guys. You cannot split the expression under the square root. So I mean, square root of 5 minus x squared. This is not equal to square root of 5 minus x. All right, that's not true. Okay, so this is not equal. Not equal. Anyway, so that's your y. So you succeed to solve for y. Then you have to check if, in order to be a function for each input x, there's exactly one output, right? Well, here, because of the plus or minus, there are two possible outputs. So because of the plus or minus, so there are two possible outputs for each input x. There are two possible outputs. Okay, so then y is not a function of x. So then y is not a function of x. Okay. Any question, guys? All right, so that's for A. For B, in B, you see there's this minus y cubed. So it's an equation, of course, in B. So again, all you have to do is solve for y. So if you solve for y, so this is minus x squared minus y cubed plus 4 equals 1. So again, this is an equation. So we have to solve for y. Solve for y. Right. So then, we can add plus x squared. So this is minus x squared minus y cubed plus 4 equals to 1, positive 1 here, right? So of course you can, let's say, subtract 4. You can add x squared plus x squared here plus an x squared here. So that would be minus y cubed on the left side. And then 1 minus 4, that's negative 3, plus x squared. All right, so minus x squared plus 4 minus 4. All right, so, well, this is minus y cubed, right? So you need to get rid of this minus. So you can, you can just divide the whole thing or multiply the whole thing by -1. So here's over -1, here the whole thing over -1. So negative over negative, of course, that would be positive. So that's positive y cubed, negative 3 over -1, that's positive 3. And then plus x squared over -1, that's minus x squared. Okay, now let's apply the third root. So here's my third root. Here's my third root, right? And then, so then your y would be equal to third root of 3 minus x squared. And here, there is no plus or minus. Okay. No plus or minus because 3 is odd. Okay, so because you have odd power, this is odd. odd power. Okay, because of the odd power. So because the power of y is odd. Okay. So because the power is odd, the power of y is odd, so there's no plus or minus. So if you pick any, any input x, like for example 0, then you're gonna have 3 minus 0 is 3, so there'll be third root of 3. So you're gonna have exactly one output, right? So there's no plus or minus. You have exactly one output for each input. So then your y is a function of x. So then y. So
Professor,
yes.
excuse me.
Yeah, sure.
The square root of y over 3, we don't have the minus sign because you divide it by -1, right? Yeah.
You're talking about this equation here, or this the third root? You are talking about the third root?
Yeah, I didn't see, like, I realized that you divided the minus y square minus
The
1.
you're talking about this -1, right? Here.
Yes.
Okay. Yeah, because you see, this is minus y cubed,
Yeah.
and I want to get rid of the minus.
Okay. Yeah.
All right. So that's why I divided the whole thing by -1. So I can
Negative over
get
negative.
negative over negative is positive, right?
Okay.
Sure. So yeah, I was saying this y here. I mean, it's a y is a function of x because for each input x, there is exactly one output. Okay, so there is only one output. Only one possible output. Then yes, then y is a function of x. Okay. Yeah. So yeah. Is there any question, guys? So you see how it works, right? Now for C, it's kind of tricky because in the C there are y square and there's 2y, and so you cannot really combine the y square and the 2y. So when you solve, you cannot really solve for y in C. But still, let's see what happens in C. So in C we have y squared minus 2y minus x equals to 2. Right? Again, this is an equation, so we have to solve for y, etc. So you solve for y, so you can oh yeah, sure. I can go up. Yeah, sure. Oops. Is that okay, Kairali? Sure. Here's just one possible output. Yeah, so, okay, thank you. So, yeah, so here, so let's try to solve for y. So here I'm gonna add plus x. So then we're gonna have, y squared, y squared minus 2y minus x plus x is 0, and then 2 plus x, right? So as I said here, guys, the problem here, you cannot really solve for y because we have y squared and 2y, and you cannot really combine this y squared and 2y. But anyway, you, I mean, actually, there are different ways to answer this question. But what we can do here, what we can do is to pick a random value of x and then solve for y and see how many outputs you're gonna have, right? So let's pick, for example, okay, so the easiest value we can pick would be, x equals to -2, because when x is -2, then the right the right side would be 0. Okay, that would be very easy to solve, right? So you want this to be 0. Okay, so that's why I picked x equals to -2. All right. So then if you pick x equals to -2, then you're going to have, of course, so then you have y squared minus 2y equals to 2 minus 2 plus -2. That would be 0, of course. Okay, so now the equation is just y squared minus 2y equals to 0. Okay, and you're going to solve for y and see how many outputs y you're going to have. So solve for y, right? And then you can see if you solve for y, then I mean, you can use a quadratic formula, or you can just factor the left-hand side. You know, you have y squared minus 2y. You can use quadratic formula because you have y squared, or you can also factor. So you can just y is a common factor. There's y in here. There's a y in here and y in here. So I can pull out y. So here's my y. If we factor out y, then to get y squared, you have to multiply by y here, right? Y times y, that would be y squared. There is this minus, so here's my minus, and then there's times 2. So 2y, so here's minus 2, right? Y times 2, that would be the 2y, equals to 0, right? So then now you have a product of two numbers equal to 0, then one of the numbers has to be 0. So then y is 0. So then this first term is 0, or the second term is 0. Okay, so then either y is equal to 0, or y minus 2 is 0. Again, guys, remember, the product of two numbers is 0. It means that one of the numbers has to be 0. Okay, otherwise it cannot be 0. I mean, if you have a product, the only way you can have a 0 in the product is one of the numbers is 0. So either y is 0 or y minus 2 is 0. So y is 0, and then y minus 2 is 0. It means that y is equal to positive 2. Right? So you see here, so what I'm saying is I got two outputs here. If my input x is -2, this is my input, then I got two outputs, right? Two possible outputs, y equal to 0 and y equals to positive 2. Okay, so we got two possible outputs. When the input x is -2, then y is not a function of x. So when x is -2, then we have two possible outputs. Y equals to 0 and y equals to positive 2. Okay, so then that means that your y is not a function of x. So then y is not a function of x. Right? Of course, you can pick a different value than -2, right? You can pick, I don't know, you can pick let's say you can pick 4 or 5 or -4 or wherever. All right, and then actually you're going to end up with a quadratic equation, right? And then you have to use the quadratic formula to solve the equation, right? And then because you use the quadratic formula, it means you're going to end up with two possible outputs, because in the quadratic formula you have plus or minus, right? Minus b plus or minus. It means that you're going to have two possible outputs, right? So then y would be, it's not a function of x. Any question, guys? All right, so now for the D is different, because in D we have a graph, right? So in D we said when you have a graph, to determine whether y is a function of x, you need to use, it's a graph, so then you need to use the vertical line test. Use a vertical line test. So what's the vertical line test? Well, so if you have a vertical line which intersects the graph at more than one point, okay, then your graph is not a function of x, okay? So if a vertical line intersects the graph at more than one point, okay, then y is not a function of x. Anyway, so I mean that's just to remind you what's the vertical line test. So in the test, guys, you don't have to write what's the vertical line test. Okay, you can just use it. Okay, so let me just graph the graph we have in the review sheet. So so here's the graph. Well, I mean, so we have an empty dot here and then an arrow here. All right. I mean, it looks like the graph in the review sheet. Anyway, so if you use the vertical line test, of course, I mean, if you take any vertical line here, this vertical line here is going to intersect at 1 point, 1 point. Here it's 1 point. Here it's 1 point. Here it doesn't intersect the graph. It's not a problem. Again, again, the test says if a vertical line test is to intersect the graph at more than 1 point. So if it intersects the graph at 2 points or 3 points, etc., then that will be a problem. If the vertical line intersects the graph at 1 point or it doesn't intersect the graph at all, then that's not a problem. Okay. So here we don't have a problem. Here there's no problem. It doesn't matter if this point is excluded. All right. It means that my vertical line here, it doesn't intersect the graph. Okay. But it doesn't really matter, right? So here it intersects the graph at 1 point. That's okay. So if you pick any vertical line, then it's going to intersect the graph either at 1 point or at no point, right? So in both cases, that's fine. So then your y is a function of x. Okay. So so in this case, so this is a function, right? So this is a function. Any question, guys, about the vertical line test? Again, you don't have to write down the test in your answer. Okay, you can just draw vertical lines and say, well, my vertical lines, you know, they intersect the graph at either at 1 point or no point. Okay, so then your y is a function of x. All right, so I guess there's no question. So then probably I can move to the problem number 2 in the first page. So problem number 2, it's about domain, right? So no, problem number 2. So this is from the review sheet again. Oops. Problem number 2. This is again from the review sheet. Right. So you have to find the domain. You have your f, you have your g. So for a, you have to find the domain of f. So domain of f of x. F of x is x minus 2 over x minus 5. So guys, we said in general to find the domain. So if you have a fraction, then you have to solve the denominator equal to 0. So just to remind you here, so if you have a fraction So all you have to do is to solve the denominator equal to 0. And if you have a square root, all right, then you have to solve the expression under the square root larger or equal to 0. Okay, so we have to solve larger or equal to 0. Okay, so this is, of course, f is a fraction, so you have to solve the denominator equal to 0. So x minus 5 is 0. Of course, then your x is positive 5, right? So we have to exclude 5 from the domain of f. So the domain of f would be any number except the 5, right? So answer, and again, your answer, guys. To get full credits, your answer should be in the interval notation. So the domain of f, or d subscript f, it's negative infinity to positive 5, excluded, union positive 5, excluded again to positive infinity. All right. So all you have to do is to exclude the positive 5 from the number line. All right. So guys, please feel free to interrupt me if you have any questions. All right. For B, so B is, we have to find the domain of g of x. So domain of, so your g of x is actually square root of x plus 3, right? So that's the square root. So I have to solve what's under the square root larger or equal to 0. So I have to solve, we have to solve the x plus 3 larger or equal to 0. Okay, so of course you subtract 3, so your x is larger or equal to negative 3. All right, so that would be any number larger or equal to negative 3. So then domain, so the answer, so then the domain of g would be x larger than negative 3, so it's negative 3 to positive infinity. Negative 3 is included, right, because of this line here. It can be, x can be equal to negative 3, right? So negative 3 included, positive infinity. All right, let me see if there's any question in the chat. Okay, there's no question. For the C, f plus g. Okay, this is a common mistake, guys. I mean, I saw this mistake in a lot of homeworks. So for C, so this is, you have to find the domain of f plus g. Domain of f plus g. Okay, so for domain of f plus g, you don't have to compute f plus g. Okay, we have a theorem which says that the domain of f plus g is the common domain to f and g. Okay, so don't compute, you don't have to compute f plus g. Okay, all you have to do is, so we have to find the common, or the intersection domain, the common domain. The common domain, right? So domain of f, it's any number except 5. So domain of f, let me write it here. So domain of f is this one here, right? Domain of g is negative 3 positive infinity. So let's see what will be the intersection domain. It's up to you guys in the test if you want to draw the, of course, in the test you have to show all your work, okay? No work, no credits, okay? I mean, when you want to find the domain, you can use the number line, okay? It's not a requirement, of course, and your final answer should be in the interval notation, right? But I mean, I think it helps. I mean, if you draw the number line and see what would be the common domain. So like here, I have here is negative 3. I have my 5 here, the domain of f. it's any number except 5. So this is D subscript F. Now domain of G, it starts at -3. All right. So that's my the blue domain. So if we have a red and a blue domains. So what will be the intersection or the common domain? So it would be this one here, of course. So it starts at -3. 5 is not included because 5 is not in the domain of F. So 5 is not a common, it's not common to the domain of F and G, right? So we have to exclude the 5. Right? And the -3 is included because it belongs to both domains, right? So then your answer should be so domain of F plus G, it's a -3 included, 5 excluded, union 5 to positive infinity. Right? And again, guys, you go from left to right, from the small number to the larger number. Any questions? All right, so if you have F plus G or F minus G or F times G, then this would be the answer. Okay, so this is also the domain of F minus G or F times G. Okay, it will be the same answer. Now for F over G. Okay, so this is in D. So in D, F over G or G over F. Let's say you have F over G. Okay, so if you have F over G, so what we have to do, guys, there's one more step, okay, or there's one more thing to do compared to the domain of F plus G. You have to exclude the values of X where the bottom is 0. Exclude X where the bottom is 0. Okay, so the bottom here is G, right? Of course, if you have like G over F, then the bottom would be F. Now here, F over G, the bottom is G, right? So we have to solve the bottom or denominator equal to 0. So we have to solve G of X equal to 0. Okay, so we have to solve square root of X plus 3 equals to 0. Okay, so then of course here you just apply square both sides. Then you're gonna have X plus 3 equal to 0. Then your X would be, of course, -3. Okay, so we have to exclude -3. Okay, so this is to be excluded. So you have to exclude this from the common domain. So to be excluded from the common domain. Right? So again, here's my common domain. This is my common or intersection domain, right? This is my common domain. And we have to exclude -3 now, right? So then the answer, so here's find answer. So the domain of F over G, all right? So -3 is excluded, so we're gonna use parentheses with -3, 5, union 5, positive infinity. All right. Again, guys, for G over F, if you have, okay, let me do the E. So for the E, G over F, now the denominator is F. The bottom is F. Okay, so we have to solve F of X equal to 0. Okay, so F of X, it's of course X minus 2 over X minus 5 equal to 0. Okay, now guys, if you have a fraction equal to 0, it means that the top is 0. Okay, this is, so fraction is 0, then it means that the top is 0. Okay, so then because if the top is 0, 0 over any non-zero number is going to be just 0. So we have to solve x minus 2 equal to 0. Sorry, x minus 2. X minus 2 equals to 0. So then x is positive 2. And this is to be excluded from the common domain. Again, excluded from the common domain. Right? So again, my common domain is this negative 3, 5, 5, positive infinity. And now I have to exclude positive 2. Okay. Again, guys, here's my common domain. In the common domain, the negative 3 is included. Okay. In the common domain, the negative 3 is included. And now I have to exclude positive 2. So that will be, so the answer here for G over F. So the answer, domain of G over F should be negative 3 included because negative 3 is in the common domain. And then we have to exclude positive 2, right? So negative 3, positive 2, union. And then we have to exclude, of course, 5 because it's excluded from the common domain. So then union 5, 2, 5, union 5, positive infinity. All right. So don't get confused, guys. I mean, in the previous answer, F over G, this is not our common domain. I mean, we excluded negative 3 here because it was F over G, and we had to solve G equal to 0, right? Now, for G over F, we have to exclude from the common domain where F is 0. Is there any question, guys? All right, so let's just finish the last one. No, yeah, last one is it's a composition, right? So the circle, again, the circle, guys, it doesn't mean, oops. So the circle, so this is for F. This is F. So F, domain of F composed with G, right? So this is, as I said, this is composition. It's not, sorry. So this is here, this is composition. It's not multiplication, right? So how to find the domain of F composed with G? So first step, we have to find domain of the second function. Step 1, find domain of, we have to find domain of G. Okay. The second function. Second function. Well, we know the answer, right? We know the domain of G, we said that's from the B. Domain of G is negative 3, positive infinity, right? From B, we know the domain of G is negative 3, positive infinity. All right. I mean, that's already done. Now, next step, step 2, we have to compute. Step 2, we have to find F composed with G of X. Okay. So let's compute this F composed with G of X. F of X, it's X minus 2 over X minus 5. So we have to substitute X by G of X. So this X in here, we have to substitute X by G. So this is my X. So then, so again, this is F of G of X. So we have an X in the top and we have an X in the bottom. Right, so here is going to be G of X, here is going to be G of X, and then there's minus 2 here, and then there's minus 5. All right, so then, of course, So this f of g of x is going to be, so g of x is square root of x plus 3 minus 2 over, and then g of x again, so that's the square root of x plus 3, and now minus 5. Okay, so I have to define the domain of this. Okay, well, so here, of course, we do have a fraction. It's a fraction, so we have to solve denominator equal to 0. So we have a fraction. So we have to solve the denominator 0. So that's square root of x plus 3 minus 5 equal to 0. So here's plus 5 plus 5. So that's square root of x plus 3 equals to positive 5. Then we use a square. So here's a square here, a square here. So then it's x plus 3 equals to 5 squared, that's 25. All right, subtract 3, subtract 3. So then your x is 22. Okay, so we have to exclude this 22 from your domain, right? Because again, it's a fraction, so this is to be excluded. Okay. So so we have domain of G. So this has to be excluded from the domain. Okay. So we have to exclude 22. So so then the last step, this is the last step here, step 3. So we have this domain of G, right? Domain of G, we said it's so domain of G, we said it's a -3, positive infinity, all right? And then we have to exclude this 22, right? So and then we exclude 22. So answer here, so find the answer. The domain of f composed with G would be -3 included, and then 22 excluded, union 22, and then positive infinity, of course. All right. So that's for f composed with G. Any question, guys? Okay, no questions. Okay, so we still have like 30 or 35 minutes. Do you want me to do any particular problem, guys, in the next pages? I mean, I can do the next page number 2, but I mean, if you have any request or any question, question 8. Okay, sure. 8. Find the inverse. Okay, sure, yeah, sure, I can do that. So, all right. So let's do problem 8. Oops. So problem 8. So this is from the review sheet. Okay, find the inverse. Okay, so find the inverse. So okay, so I'm gonna make like a table. So here's my function. So this is my f of x, which is x minus 3 over 4 plus 5x. Okay, so and on the right side, I'm gonna write down the steps. So first step, one, just replace f of x by y. Replace f of x by y. So here is gonna be y equals 2, and then we have x minus 3, 4 plus 5x. All right. Next step, to change x and y. X and y. All right. So then y becomes x, x becomes y. So here y becomes x. Oops. So y becomes x equals 2. X becomes y. Let's pick yellow. So this is y here. So minus 3 over 4 plus 5, and then y. Okay. Now, of course, the main step is to solve for y. Okay. So you want to solve for y. This is, you know, on the right side, you have a fraction. So my advice is to make the left side look like a fraction. So on the left side, we have x. So on the left side, we have x. Oops. So we have x in here. This is equal to y minus 3 over 4 plus 5 y. So I'm gonna divide x by 1, okay? Because so then both sides would be they would be fractions. Now on the right side, I wanna solve for y. The thing is, I have y in the top and in the bottom. So what we have to do is, in this case, you have two equal fractions, then you cross multiply. Okay, so when you cross multiply, then you're gonna have like x times 4 plus 5y, and then the right side you have 1 times y minus 3. Okay, don't forget your parentheses, guys. Then you you know, you distribute. So x times 4, that's 4x. X times 5 times y, so that's 5xy equals to y minus 3. All right. Again, now the idea, guys, how do we solve such equation is you want to solve for y, right? So you have to move all the y's to the same side, and everything else without y to the right side. Like for x, you don't have y in for x, right? So you have to move the 4x to the right side. So I'm gonna subtract here minus 4x. Okay. Here there's an y, so I'm gonna leave it. I mean, I'm gonna keep it on the left side. Now there's this y here. It's on the right side, so I'm going to move it to the left side. So I'm going to subtract y. All right, and here minus 3. I mean, there is no y in minus 3, of course. So then I'm gonna just leave it in the right side. Okay, so so here I subtracted, of course, for x, so I need to do the same here, minus 4x. Here I subtracted y, so I need to do the same here, minus y. Okay, so we're gonna have 5xy minus y, right? I mean, this is 4x minus 4x, cancel out. And then on the left side, y minus y cancel out, and then you're gonna have negative 3 minus 4x. All right, now you see all the y's on the left side, and everything else which doesn't involve y is on the right side. Okay, so the goal is to factor out y, because now y is a common factor on the left side. You have y here, you have y here, and y here, so you can factor out. So you can factor out this y. Right, so if you factor out y, so it's going to be y times, there's this 5x, so 5x, there's this minus, so it's minus here, and then this y here, if you pull out the y, it's actually y times 1. So if you pull out y, you are left with 1 there, so it's minus 1. right? And then there's this -3 minus 4x. Okay, now you can divide by, this is 5x minus 1, so you can divide by 5x minus 1, and you have to do the same thing to the right side, so you have to divide also by 5x minus 1. All right, so then your y, your y would be equal to -3 minus 4x over 5x minus 1. And that will be fine answer. So the inverse function, so f inverse, so f to the -1, or f inverse, the inverse function. So that's equal to this -3 minus 4x over 5x minus 1. All right, any questions? Okay, no questions. That's good. Is there any other specific question, guys? Sure, Matasam. Yeah, sure, no problem. I can do, of course, next, problem number 3 in the page 2, unless there is any special request. Okay, no special request. So then let's do problem number 3 then. Okay, this is. So problem number 3. Oops. So problem number 3. This is the review sheet again. Right? So the problem number 3, I mean, this graph is actually from homework number 2 or 3. All right. So you have the graph of f of x, and then you have to find the range of f. So let me just first graph your function f of x. Probably I'm gonna need more space. So so we have a 1 here, and then 4, 2 here, and then 3, 2 here. All right, so this is 1, 2, 3, 1, 2, 3, and then 4. This is -1, -2, etc. And so the graph looks like, and I'm going to need -4 actually. So this is -3, this is -4, this is +4. And so here's your graph. All right, so that's my f of x. Okay, so first question, guys. You have to find, we said, the range. So for the range, guys, please try to use horizontal lines. So use horizontal lines. Right. So again, this is supposed to be here. This is -infinity in the bottom, and in the top here, it's +infinity, right? And remember the idea, guys. To find the range, use horizontal lines, and you have to go from the bottom to the top. Okay, from the bottom to the top. Okay, and the range, it's about the outputs y, right? So when you find your range, you have to check your y-axis. So on the y-axis. Okay, so what I'm saying is, so I'm going to use my horizontal lines, and whenever my horizontal line intersect the graph, then the corresponding y belongs to the range. So for example, here in the bottom, we start at negative infinity, right? Here in the bottom at negative infinity, right? Remember, guys, the arrows here means that the graph here doesn't stop here. It continues and it goes all the way down, right? It goes all the way down, right? So if you start from the bottom at negative infinity, then of course, then you're gonna have intersection, right? You're gonna have intersection here and here, here and here. All right. So your horizontal line intersect the graph. So that will be the corresponding y. Here's the corresponding y. It's on the y-axis. The corresponding y is in the range. If you take, for example, this horizontal line, intersect the graph. So this point here is also in the range. Okay. So this is in the range because if you take this, any horizontal line here is gonna intersect the graph. You're gonna still have intersection. So this is still intersect the graph at 2 points. So now you arrive to the top. Of course, here you're gonna have intersection. Actually, there are like 3 intersections. You arrive until 4. So you see here at 4, you're gonna have 1 intersection here, right? But then, of course, if you pick a horizontal line after 4, right after 4, like if you pick this horizontal line here, this one here doesn't intersect the graph. Okay, so do not intersect the graph, right? So your range goes from negative infinity to positive 4. Okay. So the range. So then the range, so that's from negative infinity to positive 4. All right, and positive 4 is included because if you take a horizontal line passing through 4 here, right, you have an intersection here. So this point is included in the graph, right? So then positive 4 is included. So positive 4 is included. And if you pick any horizontal line after 4, then you won't have any intersection, right, with the graph. So then the corresponding y is not in the range. That doesn't make sense to you guys? So for the range, use the horizontal lines from the bottom to the top. For the domain, if you have a graph and you want to find the domain, you have to use the vertical lines and you go from left to right. So let me just remind you here for the domain. Use vertical lines from the left to the right. Okay. Any question, guys, about the range here? Okay. The x-intercepts. So the x-intercepts, that's the intersection of the graph with the x-axis. So then you see your graph intersect the x-axis here at -4 and at +4, right? So then the x-intercepts are, so your answer should be in points notation. So it's -4. Your y is always 0 and +4, 0. Right. So that's for the x-intercept. That's the intersection of the graph with the with the x-axis. Now for the y-intercept, so that would be the intersection of the graph with the y-axis. So here, you see this point here. So that's where the graph intersect the y-axis. So, and it corresponds to +1. So I mean, this is supposed to be +1 here. Okay. So then your x-intercept, your y-intercept should be y-intercept is, it's 1, but your answer should be in points notation. So your x is always 0 in the y-intercept, and your y is 1. The values of x at which f has a local maximum and a local minimum. Oops. So for local maximum, so we have actually two local maximums, right? So remember, guys, whenever you have like sort of, so this is C, right? This is C, right? So for local maximum, so whenever you have like, you know, like a parabola, sort of parabola, right? Which open down, all right? So then this point here, it would be local maximum, right? Now for local minimum, so whenever I have sort of a parabola opening up like this, all right, then this will be a minimum, local minimum, right? So like here in the graph, of course, so then you see here in the graph, like at this point here, you have sort of like a parabola, right? Opening down. So this point here, that would be a local maximum. And actually, it's not just a local maximum, it's a global maximum because it's the highest point of the graph, right? So we have a local maximum here, that's at -2. And here, at this point, we have also like sort of parabola, right? Opening down. So we have also local maximum at +3. Okay, so local maximum at -2 and +3, and then for the minimum, we have for a minimum we have this at 1. You see this here at 1. We have sort of a parabola opening up. So at +1, we have actually a local minimum, right? So so local maximum at x equals to -2 and x equals to +3. Then we do have a local minimum at x equals to 0, right? Here. This point here corresponds, of course, to x equals to 0. Right? Any question, guys? Okay, so then that's for the local maximum, local minimum. Then we have to evaluate like f of -2. So this would be E, right? So we have to find f of -2. Well, f of -2, of course, it would be this. So here's my x equal to -2, right? Then you draw this vertical line and intersect the graph at this point, right? And so the corresponding y, of course, it's 4. So f of -2 is +4. So f of -2 is +4. Oops, +4. Next, f composed with f of 4. So here, just be careful. This is composition. It's not multiplication. So f composed with f of 4. This is this is composition, right? So f composed with f of 4. So this is by definition f of 4. Right? So first thing, so this is like a PEMDAS rule. So first you have to evaluate what's between parentheses. So between parentheses, we have this f of 4, right? This f of 4 here. So what will be f of 4? So you have to check your graph. F of 4, it's actually 0, right? Because here's a 4, so f of 4 is 0. So this thing here, this would be 0, right? But you know, there's still f outside the parentheses. So now we have to evaluate f of 0, right? So then f of 0, of course, f of 0 would be positive 1. That's f of 0 is positive 1. The answer would be positive 1. All right. Okay. Well, then there's f composed with f of -2, f composed with f of -4. But I mean, if you understand how it worked for f composed with f of 4, then the f composed with f of -2 and f composed with f of -4, it shouldn't be a problem for you. So let's just, you know, in the remaining 10 minutes, I'm gonna do probably another problem. Let's see. For example, yeah, the problem number 4. Okay, so let's just, so again, guys, if you have any specific or special requests, you can just let me know, okay? So this is problem number 4. So problem number 4, it's about transformation, right? So this is from the review sheet again. So you have to sketch, you have to graph minus f of x plus 2. All right. So let me just first graph f of x. So f of x, I'll probably, yeah, f of x. So I'm gonna need 1. This is 2. This is positive 4. -4. And then I'm gonna need -2. Right. So anyway, so this is your f. So here's a point. Here's another point, and then 0. Here's another point here, and right here. Okay. So let me just now connect the points. This is f of x. All right. This is f of x. Now you need to graph minus f of x plus 2. Right. So now you need to graph minus f of x plus 2. Okay, so first transformation, guys, we have minus f of x. So if you have minus f of x with a minus outside the function f, then that will be a reflection. So this is a reflection about the x-axis. This is a reflection about the x-axis. Okay, so if you have minus f of x, that will be a reflection about the x-axis. If you have, of course, f of minus x, that will be a reflection about the y-axis. So we have this reflection about the x-axis, and then there's this plus 2. So the plus 2 is outside the parentheses, outside f, outside f of x. So that will be vertical shift. And you have to go, because it's a plus, so you have to go up by 2 units. Right? So first, a reflection about the x-axis, and then we have to go up by 2, right? So let's start with the reflection about the x-axis. So I'm going to use the green. First, this point here, it lies on the x-axis. This is my x-axis, of course. So this point here lies on the x-axis. So its reflection about the x-axis is going to be just the same point. Now, next, this point here, it's a reflection about the x-axis. So we have to measure the distance from the point to the x-axis. So it's 2 units. Now we have to go up by 2. Okay, so this will be the reflection of the point about the x-axis. This one here lies on the x-axis, so its image is going to be the same point. This one here, its distance from the x-axis is 2, so we have to go down by 2. Okay, so here's its image, and this point here would be just the same. So then this is the reflection of f of x about the x-axis. Okay. Okay, and then we have to shift our graph up by 2 units. So this point here is going to go up by 2. This one here up by 2. Up by 2. So you start from the green graph, right? So first you do the reflection about the x-axis, right? Then you get your green, you get this green graph here. This is minus f of x, okay? Now, the next step would be the vertical shift. So I'm gonna shift my green graph up by 2. So this one goes up by 2, here up by 2. Sorry, not that one. This one here, oops. So this one here up by 2. Let me just, so this should be green here, of course. And then this green point here up by 2. All right. So you connect the points now. This is here. Then we go down here. All right. And then up here. Okay. So that will be minus f of x plus shifted up by 2. Right. So anyway, in the test, guys, you have to, you know, you have different kind of transformations, right? You have the vertical shift, you have the horizontal shift, you have reflection about the x-axis, reflection about the y-axis, etc. Right? So you need to know, you need to know the exact formula for each transformation. So, you know, if you, for example, let me just remind you quickly. So if you have like, you know, if you have f of x plus 2, the 2 inside, okay, so then that will be a horizontal shift. Okay, or if you have minus 2, okay, so you have to shift your graph to the left or to the right, depending on whether it's plus or minus, right, to the left or to the right. Okay. Of course, if you have f of x, this plus minus 2, then that will be vertical shift. Up or down, right? Etc. Anyway, so you have to know all these transformations in tests. Okay, so yeah, Crystal, it's okay if you don't graph the first change. Yeah, it's fine. Sure. Yeah, of course. Yeah. Okay, so we have just 3 minutes, and the 3 minutes. Okay, let me just make a couple of comments about problem number 5. In the problem number 5, guys, let's see here. So the problem number 5, you have to determine whether a function is even or odd or neither. This is problem number 5. Review sheet. So what I'm saying, so for first function here, this is x cubed minus x. So this is x power 1. So all the powers are odd, then your function is odd. So all powers are odd. All the powers are odd, then the function is odd. And the function is odd. Okay. Next, f of x, x fourth minus x squared plus 1. So, you know, this is even, and this is also even because this is x to the power 0. Okay, so then all the powers are even. All powers are even. So then are even. So then the function is even. Function is even. All right. And for last one, we have x plus 1. So f of x is x plus 1. So this is power 1. 1 here, 1 by itself is actually x. 1 is actually times x to the power 0. So here we have power 0, right? So we have power 1 and power 0. So it's actually, it's neither, right? Because 0 is even. So this is f of x is neither because, you know, because we have, so in the test, you have to write down, guys, of course, you have to justify your answer. You have to say, well, all the powers are even, then your function is even, or whenever, wherever, okay? But you have to justify your answer, okay? So because 1 is odd and 0 is even, okay? Anyway, so I guess, yeah, I'm gonna stop here, I guess. Is there any question, guys? Any comment? So again, there will be no surprise. Just make sure that you know how to answer all the problems in the review sheet and the homeworks. Okay. So then you're gonna, I'm sure you're gonna be fine. Okay. Any question, guys?
I have a question.
Yes.
For when we do the graphing, is there gonna be one on Blackboard? Do we graph it on it, or we graph it on like a separate sheet of paper and like send it?
Yeah,
to
just graphing the just graphing on the sheet of paper. You
okay.
don't have to. Yeah.
And then like are the questions on the test gonna be multiple choice, or we just fill in the
No, there will be no multiple choice. It's
okay.
It's like the review sheet, you know.
All right. Thank you.
Carolina, you're saying, it's so it's from 10 a.m. to 12:15. From 10 a.m. to 12:15. Sure. Any other question, guys? So at 10 a.m. we'll find the test on Blackboard. All right. Please upload your answers on Blackboard or just email them to me. Okay.
Professor, so
yes.
We won't have any class that day. Only the test.
No, only the test. Yeah, of course, only the test.
And that will be this Wednesday, right? Just confirm.
Yeah.
Okay. Thank you.
Excuse me, Professor. It's going to be a multiple choice.
No. There will be no multiple choice questions. No. It's like the review sheet. No multiple choice. Yeah.
Professor.
Sure. Yes.
So we have to email it or submit by Blackboard.
Yeah. Like what you do, like for the homework, the same thing.
Okay, Professor.
Sure.
Okay. We're going
Thank you.
We're going to submit on Blackboard.
Yeah. You can submit. You can upload your answers on Blackboard. Yes. Like what you do for the test. For the homework. Yes.
For the homework. Okay. No problem.
Yeah. Same thing. Yeah. Okay, guys, I'm gonna stop here. Well, wish you good luck on Wednesday. Stay safe and take care. See you next time.
Thank you, Professor. I was a little bit late, like 5 minutes.
Okay, yeah, I got your name. Thank you,
Thank you, Professor.
Thank you, guys.
Is the video gonna be uploaded by tonight, right?
Yeah.
Thank you.
By tonight, yes, sure.
You got my name?
Yeah, I got yours. Yes.
Okay.
Thank you. Yeah. Thank you, guys. See you.